Good morning to you all. I'm going to talk to you about plant water status in Sunburn in Japanese plums. The high summer temperatures in the Western Cape province, with a combination of high irradiance, cause the prevalence of sunburn in the orchards. This reduces the market value or the export value of fruit. However, we also have high temperatures in the absence of irradiance, also contributing to disorders such as peat burn and gel breakdown. These are much more prominent in cold storage. Previous research and post-harvest factors mostly focused on sunburn, mostly focused on apples, and yet plums have a huge market share. And it was through that research in apples that we got reports that low plant water status increases the incidence of sunburn. So we set out to investigate the pre-harvest climatic factors affecting fruit quality of plums, particularly sunburn and heat damage. So we looked at the role of orchard climatic factors by manipulating orchard conditions through early and late pruning, and then comparing that with no pruning treatments. And then during the hottest part of the season, also incorporated shade nets. We also investigated the effect of plant water status on sunburn, inspired by findings from apple research, where we manipulated irrigation levels, high, low, and comparing with normal farmer irrigation levels. We also tried to get an understanding of the physiology of peat burn and gel breakdown, which is mostly caused by high temperatures and anaerobic conditions that deplete oxygen within the fruit, and we have carbon dioxide concentrations being elevated. But due to the time constraint nature, I only focused on the objective where we looked at plant water status on sunburn. So I'll just give a brief overview of this. We worked with two cultivars, African Delight and Letitia, whereby in African Delight we had half irrigation, and then we had the normal farmer control irrigation, and then we doubled that. And for Letitia, we had early and late season experiments where we withheld irrigation for 14 days, and then we had half irrigation for that same period, and then the normal control was the normal irrigation. So we carried out a lot of measurements: soil moisture content, stem water potential, photochemistry to see how the plant was dealing with the energy load, and obviously the effect on food surface temperature, and the evaporative cooling capacity by measuring canopy temperature, chlorophyll fluorescence to get the effects of photoinhibition, and also looked at antioxidants, concentrations of glutathione and ascorbic acid to see how the plants were grappling with stress and eventually sunburn. So we had that arbitrary 0 to 5 scale of measuring sunburn, where, as you can see, 0 was no sunburn, and then 5 was the severest. So when we had reduced plant water status, then we had stem water potential going down in photosynthesis, as well as the maximum quantum yield of photosynthesis. This is just simply a measure of tissue damage due to overload of energy. And then fruit surface temperature was going up, and canopy temperature as well as sunburn. And also the total antioxidants, which was an indication that the fruit was undergoing stress. So I'll just show this for the African delight, where if you look at the control here, the control, we had lower sunburn compared to the no irrigation treatment. But then when we tried to double the irrigation here, you see that the control and the double irrigation did not have significant differences in sunburn, and yet the half irrigation treatment had higher sunburn. And here for this no irrigation treatment, we have the class 5 sunburn being more prevalent. So in conclusion, we would say that water stress, and that was particularly in the late season, it increased sunburn in Japanese plums. But as you have seen that if you increase irrigation beyond a certain point, it does not reduce sunburn. And although we had a reduction in quantum efficiency of photosynthesis, photoinhibition does not seem to be the only factor affecting fruit surface temperature. We could have factors such as loss of evaporative cooling due to reduced irrigation. And I would like to acknowledge the following. Thank you.